Hi, this is Ariana, and these are my results and procedures for Lab 2, which involves studying the interactions of charged tapes. When objects are moved around in different directions, rubbed together, or pulled apart, they have the capability to acquire either a net positive or net negative charge. With this lab, we'll be focusing on adding excess charge to an everyday object, such as a piece of clear tape. We'll also be utilizing a computational model to digitally visualize our results. Some fundamental principles shown in this lab include the electrostatic interactions between molecules, which deals with calculating the electric field and electric force produced by a charged object, the forces that remain in static equilibrium, maintaining conservation of charge, and the distribution of line charges versus point charges. So how was the main charge piece of tape, or U-tape, created? When two pieces of tape come into contact with each other and they're separated, it leaves one tape with excess electrons and the other with a deficiency of electrons. Some assumptions made for this experiment include assuming that the charge is evenly distributed along the length of the U-tape and that all the U-tapes created have the same exact charge. We can also assume that the atoms in the tape are tightly packed into squares. I then began by observing the interactions of the charged tape with other molecules. When the U-tape was placed near my hand, I saw that the U-tape was attracted to it, indicating that they were either opposing charges or my hand was considered neutral. When the U-tape was placed near my negatively charged pen, they were shown to attract one another, indicating that the U-tape was positively charged. When two U-tapes are placed near each other, they will repel as they have similar charges. Lastly, when the charged U-tape was placed near the neutral book, they were shown to attract to each other. This is because positive and negatively charged objects maintain a slight discrepancy in charge in comparison to a neutral object. Therefore, they develop an attraction to one another. When setting up the experiment, I started by placing two books a certain distance apart, which secured the upper U-tape. I then held the lower U-tape, bringing it closer and closer until they began to repel and the upper tape rose above its original position. The distance between the two tapes when they repel was recorded and labeled as R, which will be shown in the data measurement section. The forces that act upon the upper tape are the electric force from the lower tape and the force of gravity acting downwards on the tape. The first piece of data collected was the length of the piece of tape, which was an average value derived after multiple trials. We were able to then determine the mass of the piece of tape based on the length, which was calculated to be this value shown. And as previously stated, the distance between the two charged tapes, known as R, was recorded as well. The gravitational force utilizes the equation mass times gravity, giving us this value shown. We note that the sum of the forces in the y direction for the upper tape was 0, which means that the gravitational force is equal to the electric force, giving us that same value of 2.256 times 10 to the negative third newtons. We can then plug that value into the electric force equation to derive the charge of the floating piece of tape, which is 2.55 times 10 to the negative eighth. This value is derived using the point charge equation and is a recap from Lab 1. Moving forward, you will see calculations derived for a line charge through the use of the computational model. I'm going to go ahead and give a quick rundown of some of the most important parts of the computational model code so you can get an understanding of the thought process behind it. I started with the constants and the Q charge value 4.21 times 10 to the negative eighth newtons, which was obtained through a guess and check process. I then applied the electric field equation of a charged particle that was seen in previous labs. The next component was the line of charge function that was already given, but the way that it works is finding the charge of each point along the line. In my case, the number of points along the line of the tape was 10, and the more you increase that n value, the more accurate the computational model will be. Another value I had to edit was the scale factor for the electric field, and we then had to calculate the values of electric field by adding together all the infinitesimal cross-section electric field values together to get our model. As the electric force and gravitational force values are similar, as shown here, that is indicative of an accurate Q charge value previously stated as 4.21 times 10 to the negative 8 newtons. So we were asked two questions in relation to our lab. The first compared the point charge value versus the line charge value, and the line charge value is noticeably bigger because it is essentially multiple point charges added together. This increases the gravitational force on the object, which requires more electric force to keep the tape static in the air. The distributed charge model is more representative of this charged tape because the model is more complex with multiple point charges versus the one modeled in the previous lab. In conclusion, I learned about the aspects of electric force and electric field by applying them to an everyday object such as a piece of tape, as well as how to apply this concept to model line charges on GlowScript. I was also able to apply the principle that forces remain in static equilibrium, which is shown when the upper tape remained fixed at a certain distance from the lower tape. Conservation of charge was seen when the U-tapes were created, as no charge was lost, there was only a transfer of electrons between the base tape and the U-tape. And when calculating the line charge of an object, like a piece of tape, you end up breaking down the object into smaller components as point charges to get a more even and accurate distribution of charge. Thank you.